All right, so we are back. Hopefully most of the participants have returned, and let's now move on to the practical presentation of the software.
Hi, welcome back. So in this part, I'll give you first an overview of the CCaLC tool, and then we'll continue to model a study or to demonstrate how to conduct a study in that tool. Put the full screen. Okay. So what is CCaLC as a tool? So this tool was developed at the University of Manchester by our team, and I was one of the team members. The objective of this tool was to develop a tool which is user-friendly and can be used by business or industry by non-experts. So normally, as I was saying, often for LCA studies, you need some sort of expertise, which may not be the case with relatively small business or small or medium-sized industries. Therefore, we focused on developing a simple-to-use tool, and the tool was developed in close collaboration with various industrial partners. Also, even though this tool should be simple to use, but it should also it should be robust. So it should follow the internationally accepted methodologies, which, as I was mentioning, there are two standards. One is ISO standard for life cycle assessment, also this British standard PAS 2050 for carbon footprinting. So we made sure this tool follows these methodologies in its spirit. And this tool contains comprehensive databases, because in LCA with a lot of time we require a lot of background data. So around over 6,000 database items are there on material, energy, transport, packaging, waste, and part of the data we have from Eco-Invent database, and they have allowed to us to use some of their data. Also, we collected as part of the project data at that time available in literature for various these substances or processes. As Jakob mentioned in the introduction, this tool is available free of charge, as it was developed by public funded. So it is available on this website, ccalc.org.uk. Anybody can download and use it. And these are just some of the collaborators which cooperated with us in terms of providing guidance, how to develop or what are the features they would like in the tool. Also, they provided their data for us to make some case studies in the tool. So what can we do with the CCaLC tool? So firstly, of course, we can assess the carbon footprint or carbon intensity of any product, process, technology, activity. The tool can quickly show in a graphical form where are the hot spots or major contributors to those carbon footprints. And as a result, then can help us in identifying low carbon option or kind of alternative or improvement opportunities. In addition, the carbon footprinting, this tool has another feature we have, which can help in calculating life cycle costing. We call it as a value added. So in each stage or each part where the cost data could be entered by user, and then it can also at the same time would calculate the costs of the product or process. Besides carbon footprinting, though that carbon footprinting was our main objective, we have six or seven other environmental impacts within that, including acidification, ozone depletion, human toxicity, water footprint, and primary energy demand. So now I'll open the tool, and so that we can have a quick look on the first of the tool at the various features, and then we'll start with the case study. So when you download the tool and open it, then you will see this as a screen. So on the top left corner, where there are various buttons like file, case study. So under files, options of like typically under any Microsoft application, or you can have open new study or save as, etc. And also it can show various case studies within that you can open. Under the case studies, there are several case studies within it, and under 5 these categories under biofuels, chemicals, energy, food and drink, packaging. I'll open one of them shortly, so and to show what it includes. In addition, you can import data or export in terms of the once you have completed the analysis, you can export whatever the graphs and tables to say in Excel, and where if you want to use it to for your own presentation and beautify or modify in a way to, you can do that. This button could help you quickly look at the summary, and I'll come back later on once we have, and also comparison. Under the help menu, there is a manual of this tool available. So if you click it, it will open a PDF file. I'll just open that, and you can see a full manual of how to use it, and it goes through one step-by-step process how to conduct a study within the tool. So if you are while doing a study, if you are having any if you're not sure about anything, you can always refer to this manual. This provides a very detailed guidance on how to conduct a study. So when we open the tool, we'll see this as a blank screen where it shows, as I was saying, functional unit. The green fonts here are shown as for water footprint, and red as the values of the carbon footprints. Also, there is an option which we can change. Instead of water footprint, we can see the cost related or value added information. So if I click this then the font here as shown as blue. At the moment is a blank study, so everything is being shown as a 00, but once we open the case study, we'll see some values. So basically at the top screen, we would be able to see these 4 main stages. So it's like what are the raw materials, then we can include transport, production, storage and use. So this also on the left column, there is a enter system details where we provide some basic information about the case study, what is the functional unit, and if we want to change the units of our analysis in terms of kilogram, or what if instead of kilogram we want to change to tons or grams, etc. Same for energy. And also in terms of currency, for value added, we have 3 options: pound, euros or dollars that can be and change accordingly. And also in addition, user can enter some information about the case study as their own notes if they want later to use to remember those. So now I will open a case study where we will explore some of the other functions of the tool. So let me open a case study. Say let's open a paint. So I'm just opening one study for solvent-based paint. So if I open that, this study is already inbuilt, which we conducted with one paint manufacturer, and so this study, now we can see it says study for the solvent-based white paint, functional unit is per 1,000 kilogram or 1 ton. So this study was conducted, and at the bottom here it will show the quickly what is the carbon footprint of this. So, and since we didn't have this information for value added, but if we could add value added, then it would also show the cost related information. So let me now click various those stages. So if I click under raw materials, here we define various raw materials which are used in that paint manufacture, for example, additives, binder, fillers, pigments, etc., solvents. And these data are entered by user, which is like we enter this data while conducting study, and these values for the carbon footprint data are already built in within the database. And then each these value the total impact would be shown here in this column. If we have a cost data, if we would have added, then it would show the cost data as well here. And this will provide more further information, what are the database section, etc. So it's material. Here we can also define any energy or packaging used within the raw material. So packaging, if they are coming in a certain packaging, we can add those packaging, and it will also provide the packaging related carbon footprint. So if we want to add any new material, we can click on define material. When we click on define material, we'll see three databases options. One is CCaLC database, another is avoimen database, and another is user defined. So avoimen database, as I was saying, this is database from the avoimen. They have allowed us to use it, and within that you could see data under various categories. So agriculture, biomass, chemicals, plastics, oil, paint, etc. So, and under each there are various data points. So for example, under agriculture, we could look at various fertilizers or pesticides, as well as even the agriculture product, for example, here are available as well. So various grains. So it contains the background data on on their production of those materials. Under the CCaLC database, this data we collected from literature. Again, it has few categories. So agriculture, biofeed stocks, construction material, chemical. So if I click on one of them, you could see, so under chemical, again, there are various chemicals. These values are available. If I click on any of them, we could see carbon footprint value, when was this data collected, and what are the sources, etc. The user defined generally would be, it will be blank. It allows user to enter their own data. So here you can, when you click on user defined, it will allow us user to modify and create new data. And you can, if you have your own data for a particular process or substance which you want to use in your study, you can name this here and add those. If the carbon footprint data, if you have other impact data, you can add and update the database. It will, then this data will be stored in your database. And besides material, there is a energy related same database similarly. So avoimen would have a lot of energy, from electricity to diesel or natural gas or different heat sources, and biomass data, and same we can do through user and material. Also, this function also for all databases, we have a search function, because since there are more than 6,000 data points in, it may not be easier to go and look each, but so maybe sometimes it's easier to just click search and type the substance, then it would have to find, if I click search, and then it allows the option of searching. And if I type that name, it will allow, for example, if I want to look at the hydrogen. So if I click here, hydrogen, and then it will show me what are the data points available. And within each data point, say, I can look from further what is about this. So if there are various data points for hydrogen, it could be hydrogen is produced from natural gas, hydrogen is produced from reformer. I can just select and see, is it appropriate for me, this value? There are some comments data, or if we know this is the appropriate, we can directly select. If not, go back and select the another substance, etc. And we can then use that data point for our study.
And we have a question, Harish. Somebody's asking about if there is anywhere in the software, if I understand correctly the question, if there is anywhere a place where you could define in a comment perhaps where you found numbers that you are using, probably the amounts. I assume that if you hear the amount of additives and binder and filler and pigment solvent, so if there is anywhere a place to document the source of the data.
Yeah, so if I just go, one is you can here, for example, under comments, you can just overall for the system, you can put your notes. So here, just as an example, we have shown that what is this study, what it includes, system boundary, etc., and from some primary data and what assumptions we have made, for example, etc. That's one point. And the other point, and also here you will add any, who has conducted that study, etc., when it was done. The other point where if we have a particular data for a material, say you want to use 10 kilogram or etc. Let me see if there is option it allows. Yeah, so comments on the material use. So if I select, say, let me select a particular constructed material. If I want to select, say, concrete precast, and it goes to manufacturing. And if I put whatever 2 kilogram here, and then I put on the amount, if I say, okay, this data I've obtained from this particular source, etc. So you can add your comments, and that those comments will stay within the study. So if later on you want to come and check, you want to add that this data needs to check, changed, etc., you can do that. Does that answer your question?
Yes, it answers the question. Yes.
Okay.
Great. Thank you.
All right. Yeah, so in the short, yeah, there are options available within that. You can document your notes, brief notes about whether any assumptions you made or any data sources, etc. So that was the section on raw material. So once we have defined, for example, these raw materials, they would be shown here, and then we can define say, if we have to define transport. So we could look at because these raw material may require some transport before reaching to production stage. So we can click on this transport button, and that here it will allow us to define transport, what type of trucks is being used, how much distance. Here we have used same truck and same distance, but it can be modified as well. And if the truck is empty return, you can click, etc. So if I click on this substance, I can modify. So instead of 24 truck, now I'm taking it through this different data point, or through by air, for example, if it is travel, and then what is the distance I can change if it is traveling 5,000 kilometers, etc. So that will be. And the other thing is, whenever we are entering data, it will always ask us the quality of data. So always, if we didn't enter it, then it will show a message or go back. So you have to select what is how we have shown as 3 indicators: low quality, medium quality, high quality. Again, the detail about these indicators are available in the manual. So if the data is a high quality, it means it is being measured, obtained from a primary source, and is very reliable, then we would put high quality. But if we have just estimated based on our knowledge, then it could be medium quality. But if we don't know much about it and have assumed or taken from a secondary source, then it could be low quality. So it's a more some sort of personal judgment or professional judgment. Based on that, each indicator needs to define, and this data quality will then later on we could see overall the quality of the study data, and then can show whether the data needs an improvement or not. Then under production stage, here any production system we have allowed up to 10 stages can be defined. So here, like the first stage we have named as a manufacturing and packaging, etc. So, and once we define within these stages, for example, under this paint manufacturing, we we can define how much these raw materials are already defined, so they will be shown here as a grayed out cells because we defined in the previous stage. But the energy or any emission occurring from the manufacturing facility, how much waste is disposed. So these all can be defined by clicking on those buttons. And yeah, and again, this will quickly, every stage, once we show or define them, we could see the carbon footprint value. And on the here right hand column, we can also see mass balance. Again, for some processes, it is important that we define mass balance. If it is incorrectly, then it will show that, oh, there is some mass balance or some of the missing substances which might be here. So we may have to account for that as well. In here, there are these buttons we can click any. So define stage would allow us, again, here you can put about any further details about comments, as there was question about this stage. So if this particular stage, under what conditions the data have been obtained, we can do that. Then we have output would allow us what is the output from this stage. So here we have shown as a pant, but if there is anything else is coming, we can also mention. The other option is also co-product. So output, this is as a main product, but if there is a co-product, we can define as well. So if it's often in industrial processes, there may be more than one product. And so for example, it's a combined heat and power plant. It has electricity and heat as well as output. And if our functional unit is to assess environmental impact of electricity, then heat is a co-product, and we can often use allocation to share the burdens between them two. And once we have defined product, then it will allow us where this output is going, whether it is going to next production stage, or it is the end, it may go to storage or use stages. We can send it accordingly. And also the product is whether it in terms of mass or in terms of energy. So we can enter data accordingly. Beside product, if there are direct emission within that process, we can define. If we are just focusing on carbon footprint, then maybe just look at the similar subset, which is greenhouse gas emission, and select which emission is occurring from the database and add the quantity. For example, here we have carbon dioxide here as. But if we want to assess also other impacts such as eutrophication, then we have option of defining further. So emissions to air, soil, water, or marine water accordingly, and then that will allow us to calculate other impacts such as eutrophication, acidification, or human toxicity. Also in each production stage, we can define if there is any waste, what happens to the waste. So is it going to incineration, for example, from database, if it is incinerated, landfill, or treated, if it is a wastewater, treated. We have some examples also of recycling. So what happens, we could add also could select from the equivalent database, which contains further more data on this various waste streams. Or same way we can have our own user data. This option of land use change, it is available. It's generally only applicable for agriculture process where we know the land use change is happening. So if it is industrial or other processes, this is not relevant. And on this point, we can see the option is called if we have a co-product, then it allows us how to allocate the impacts between co-products. So since there is no co-product defined, this function, it gives that there is no, but if we have, we'll see later on if there is co-product, how can we allocate, like either whether we do allocation based on mass or its energy values or economic, etc. And then under each stage, we will see the carbon, this option of, again, seeing the carbon footprint values, which we are seeing here as a total in tabular form, we could see in a graphical form as well. So if we click here, we see the carbon footprint coming from, in this stage, from energy or as a direct emission and waste. And even if we want to look further under, if there are further breakup, we could look at what is contributing within the energy. So is it caused by electricity or LPG and natural gas? So that allows to us to see detail of every data we have entered in each stage. So as I said, then also sometime it's possible the production can be happening in two different places. So there might be some transport involved. So we can, if there is a production is not happening at a one stage, we can have a transport, and we can add again same function of transport for that. And after production, if it's again the product is sent for to whether it is storage, we can define whether it is stored, and if there is any use of energy during storage. Some, for example, food product or industry may require refrigeration, then we could add energy usage or any waste here. Under use stage, some products do contribute during the use. For example, if we are, say it's a food product, then if we may want to include cooking, etc. So that here there is an option of we select data for energy for the use stage. And also in define use stage, we have some information on some appliances. So like fridge, freezer, if we during the use it is stored, or it's a washing, or electric ovens, or even within, rather than using of any appliance, emissions are occurring directly because of use, then we can also define each emission at that stage. And any waste generated can be added as we can add in other stages. So, and if I also waste, though we can define under each stage, it shows here transport of waste. If it is waste coming from production, we can again click here and select whether it would require like 100 certain kilometer transport to go to the treatment facility, we could define. And if I click on waste management, that it will give me again, show me a summary of the different wastes which we have defined and what is their carbon footprint. And we can also look through in the graph from where that waste stream is coming. So I think we have got the one thing which I wanted to show. Yeah, once we have, say, completed a study, we could look at in a more detailed graphic form, carbon footprint as in a study, and go in further look into the hotspots under each clickable graph buttons and find more details. Also, if I go look at the summary, we could see all data we entered as in a summarized form. So we can cross-check the data, or it provides as a quick, tabular form, what we have used and added in the data, and what might be missing could be added. Also under summary, we could look at the carbon footprint summary, which will show one in a tabular form, the value emissions occurring under each stage. Also a quick in a pie chart form, the graph or bar charts from various stages shown. We can look at the other impact summary either here in a tabular form, or in a clicking here all graphs, where we could see carbon footprint, acidification, eutrophication, and so on. So all impacts. Again, if there is any missing, because if there is any missing data with the other impacts, then it will also warn that there are some missing, because carbon footprint data is, though we have added for every data points, but for others, some of them we couldn't find the data for example, for acidification or other impacts, then it will give us that these data some of them are missing, and which if user wants can find it and add it. In addition, there is also energy summary, maybe if there is energy data, but since we don't have much energy at that time data, it's not, but now one can add. The other thing which here is, as I say, this can be used as a comparative. So if we want to compare, we can always click as a here. So we want to see carbon footprint comparison. So if we click, and then it allows us up to 3 comparisons. So at the moment they are showing blank, but if I click here and say add, for example, current analysis, and then it will add all those values for current analysis. And if I want to say compare with the another study, so I click add from case study, and say instead of now solvent based paint, I want to compare solvent free paint, and then they have the data has been added. And it's a tabular form, maybe not visible, so we can also look in the graph here or charts. So then they will say, okay, how 2 studies compare here. So in terms of total carbon footprint, as well as in terms of different stages. So, and that's how it can help in comparison. Yeah, the comparison can be done not only carbon footprint, but if we have added data for water footprint, value added, energy, etc., that can also be shown. And the other thing which I wanted to show is about the data quality. So that is, as I say, at each point you will be prompted to put a quality indicator low, medium, high, and once we have completed this study, we can look at the overall carbon data quality. So for example, here, since we have a lot of data from industry, so then direct data it shows as a high quality. But if we have done this based on a maybe secondary or tertiary data, then it would be showing a different quality at this. It will, and through that we can identify a particular process which has a low quality, for example, data. We can go back and try to improve the data, or if not, then at least we could put it as a kind of a disclaimer that there is a uncertainty with that data. And as I before said, there is a while doing that, the help is available under CCaLC manual. Also, we can be contacted to answer any questions on this function of the tool. So this was just a brief an overview of the different features of the tool. And next we can start modeling a particular case study within the tool. And if there are any questions at the moment on the tool functions or features, I can answer. Otherwise, we can move to the next part of the presentation.
Thank you for this initial introduction. Before anyone would write any question, please write questions if you have anything to ask. And I have here 2 questions ready. First relates to the comparison of different case studies or different scenarios. So, is it possible to save your own project, your own system analysis for future comparison with another one? And can you, for example, compare different scenarios of your system that you would vary, for example, the distance or different type of raw material used in your product? Can you somehow easily compare different scenarios? So that's one question. And the other question would be if there is anywhere in the documentation an explanation of the data that is available in the software, like kind of each of the unit process, so that even a non-expert would a little bit better understand what it means if he or she takes low alloyed steel, for example, from the database.
Okay. So first question was related to comparison of your own. So here, first, whenever we conduct our own study, we can save it and save as, and then it will be saved on your computer system, and then again open it. But when we go to comparison, for example, I click here, comparisons. So, and on this point, for example, here, when I click on the one of the place, it will ask me, gives me 3-4 options. So one is the current analysis, another is case study from the built-in, and other is the saved analysis. So saved analysis is your own, which you have saved. And then it will, when you click it, then it will ask where you have saved your study previously, and you can open it. So that's yeah. So in short, yes, you can compare your own study by if you have changing various different features. So once for a particular scenario you did it, you save it under some name, and then make modification in the study, and then you can add those for those in a comparison here, and then it will show besides each other. Does that answer, or do you want further?
Yes. Yes, thank you. I think this is exactly what I meant. Yeah. So basically, you would, if you want to compare different scenarios, you would save them as separate projects.
Yeah. So yeah. It will at the moment it can have only one as a current study, but once you saved it on your folder, you can open it and access it to
Yeah.
And then also it has a clear data. So if I want to by mistake, or I want to change it, I just clear the data. It will remove that data from there. Okay. The next question, sorry, was can you repeat that?
The next question was just that since the tool is kind of meant to be used also by non-experts, at least that's the intention of the tool, and also that's our intention in our project. Then I was thinking that a non-expert is not maybe fully familiar with all the different types of materials and hasn't maybe done an LCA before. So it might be a bit difficult to choose from the drop-down list of different raw materials or different trucks, for example. Maybe let's talk about transport. It's maybe easier to understand. So you have the different trucks of the different payload capacity, these 22 tons and 7.5 tons. So for an LCA practitioner, it's understandable maybe what kind of truck roughly it is, but for a non-expert, it might not say anything what a truck 22 tons really represents. So I was just wondering if in the documentation or in some other separate document there might be an explanation of these different unit processes that are included in the software, or if one should refer to, for example, EcoInvent's own documentation.
Yeah. So we have some information under like each data point, especially for EcoInvent about that data point. So under here, when you click on say particular transport mode, this was again ILCD database. So this gives under comment section little bit about information about this source. And if you want a little bit more about the information, then probably you want to look at their reference. Well, so and then for example, if I look at EcoInvent database and EcoInvent, we may have a little bit more information. So there, let's go under transport. Then there are various trucks available, and means one thing is if user are not sure, then they can maybe pick one average or commonly used, that type of in that cases. But otherwise, in those cases, it's also option is select one, and then maybe keep experimenting, changing a bit. How does the result change by taking a different option? The information under each would be kind of that type. So what is this inventory data includes, etc. under this is provided. And some of this comment. The more data for that are available. So for all EcoInvent database is available on their EcoInvent website on how they have calculated those data and all the assumptions made. Those can be, but at the moment I don't think we have that detailed guidance on to that level which material or which substance to select. It provides some information to means in a way that user can try, or otherwise maybe that user may have to look a little bit more detail of those options. I think.
Yeah, thank you. I think this answers my question. So there is the field with the comment, so that there we can see a bit more what the process represents. So I'm looking at the chat. I think that we don't have any questions now from the audience. So I guess we can move on to the next or to the last part of the webinar.
Okay.
The Circwaste project receives support from the LIFE program of the European Commission for the production of its materials. The views reflected within the content are entirely the project's own.